It's important for us to be on the leading edge in aviation and improve it for future generations. My name is Debbie Martinez, and I work to help develop innovative technologies to advance aeronautics. We're here for the general public and make it safer and quieter and all the good things that the general public are expecting in aviation. Industry looks to us to partner with us because we are able to provide the top minds in aeronautics and able to solve problems that are normally not reachable by the industry. We're actually trying to think outside the box. What's next in aeronautics? How to improve flight? I also enjoy doing outreach efforts here, and that's particularly focused on the young girls because I want to bring more girls into STEM careers. I will give them an example of being a woman that can be an engineer, can be a mother, can also have a pilot's license, or that they can do anything they would like to do. And that's what we like to say, we're with you when you fly.
Mars 2020 is a very exciting mission. Hi, my name is Andrew Johnson, and I help spacecraft see where they're landing. The lander vision system is used for taking pictures during landing, and it estimates position. It allows them to land at Jezero Crater, which is the place where they can collect the best samples. My work ramps up again when we start checking out the hardware that's on the spacecraft. And we do that 3 times on the journey to Mars. So my work has definitely changed, like it has for all of us. I work at home almost every day. Being part of the entry, descent, and landing team, we are very used to working remotely because our team is spread across the country. We have people in Houston, in the Bay Area, at NASA Langley. My dad took me to his place of work and I worked on a mainframe, and I've been using computers ever since. And then the mystery of space really inspired me, and I'm working on Mars sample return, which could identify signs of past life.
I think what drives me the most is really just seeing a technology that was developed here by our team being put into practice on helping NASA actually explore greater regions than they could before. My name is Colin Krieger, and I get to play in the sand with robots. My primary focus is on developing tires that can be used in space, not like when we're driving on roads. It's usually really sharp, jagged rocks, really soft sand. This particular prototype consists of coiled springs woven together in this flexible mesh, but we also have integrated a shape memory alloy. Think of like a Coke can. You squash in your hand and let go, it doesn't come back to its original shape. You've permanently deformed it. With shape memory alloys, you can undergo 30 times more deformation before you see any sort of permanent change. So we actually built a large version of the same technology, but we scaled it up so it could support 2,000 pounds and drove it on a Jeep Wrangler. I have a family at home with 2 little girls. We travel a lot as much as we can. How we like to travel and kind of explore ties into the goal of these roving vehicle missions. There's a lot of different areas we want to explore, and we need the ability to actually explore these regions.
Every day I'm learning something new. It doesn't really seem like work in a way. It's just a passion that we're pursuing. I'm Helen Wong, and I help spacecraft enter atmospheres of other worlds. There's a lot of technology that goes into entry systems. We take all of that high energy that we encounter and we have to divert it away from the payload. This is a woven material, and this is really the new way of constructing a heat shield. So if you think of like how an umbrella pops out and becomes larger, that's what Adept basically is. I love finding out all of these things. I grew up in the middle of seemingly nowhere, never really thought about space exploration. And one day we had an astronaut who came to my school and brought some space shuttle tile. And I thought that was just fascinating. And here I am today. I'm working for NASA. I'm working on heat shields. We're really trying to explore the entire solar system and to have tools and technologies in our toolkit so that when we decide that we're going to go to Titan, when we decide that we're going to go to Venus, we have the ability to do that.
On a 1-year mission, a crew of 4 would produce around 2,500 kilograms of trash. I'm Annie Meyer, and I'm turning trash into usable resources. So we're taking that trash and converting it into gases that we can use for either venting off a spacecraft or using it for fuels. So I'm standing in front of what's called Oscar. It not only produces these gases, but it's reducing the trash volume. No one likes to sit in a room surrounded by their trash, and neither do astronauts. And so the things we're studying for converting trash into gases has to be safe for the crew and therefore safe for use on the planet. My grandfather was actually a sanitation worker in the Bronx, and so growing up I was very aware of trash all around us. And I was always curious, how can we reduce our waste or convert it? But I really try to take it home with me and do everything from composting, trying to live as zero waste as you can, show others that if I can do this, you can do it too.
If we're gonna have astronauts living on the moon and Mars, you need power to be able to live in space. My name is Dr. Diona Hernandez Lugo, and I manage a team that develops power system for future space exploration. Kilopower is a nuclear technology. This setup here will be the actual size of the reactor, and it's a fission system. The heat comes all the way up to these engines here. That gives you the electrical energy that you would need then to be able to power instruments or habitats, to be able to go and explore the moon as part of this Artemis program. To work for NASA was a dream, really. Living in Puerto Rico and watching those shuttle launch on TV, I always wanted to work here. Growing up, I always asked a lot of questions. My mom bought me a small microscope, and that really is what changed my interest into science, to work on technologies that can potentially take the first woman and the next man to the moon. It's really a dream come true.
I got into robotics because I wanted to help people. I'm Kate Hamilton, and I write code for robots on the International Space Station. My sophomore year of college, I heard about a program which places people with disabilities in high-level internships. And lucky me, I got to do an internship here at NASA, and I've been working on astronomy for the last 3 years. Astronauts have to take surveys of the ISS, and this takes them a bit of time. If we can create a payload for astronomy to do that, then that would free them up to do more science. Everyday task can be hard for me, so I really wanted to dedicate my work to making robots that can really help us in life.
I work with different technologies that will enable scientists to get their instruments to wherever it is they need to get them. My name is Katelyn Carpenter, and I'm a robotics footwear designer. Any way a robot is going to interact with anything, whether it's going to pick it up, going to roll, whether it's going to fly. We've been working on Puffer, the pop-up flat-folding explorer robot. It goes up very steep surfaces on Mars, has a microscope on the bottom, so we can get the geologic history of Mars in that location. It was that easy to take the wheels off. It's pretty fantastic. One of the things that was a huge passion of mine was gymnastics. I learned that there's many ways that I could move my body. The joy of having your body move to where you want it is something that I always really appreciated. So my background in gymnastics allows me to think of all sorts of different ways it could possibly get over an obstacle, get to a location that it needs to get to, or perform some trick that has never been done by a robot before.
We have a lot of meteorites. They fall all over the Earth. Might even be able to find one in your backyard if you're lucky. My name's Glavin, and I search for the chemical building blocks of life in rocks from space. I've been to Antarctica to search for meteorites. This is what we call making meteorite tea. One of the challenges that we face is that these samples, when they hit the Earth, they immediately become contaminated. So each one of these peaks represents a different organic compound. So OSIRIS-REx is NASA's first asteroid sample return mission. This will be the first time that we actually have pristine asteroid samples in the lab to study. And so I'm hoping that Bennu will reveal its secrets about some of the early solar system chemistry, including the formation of the building blocks of life. I can't wait for these samples. Ever since I was a kid, I loved rocks. And I think what I like most about them is they're all different. Every time I try to guess about what we're going to find in a meteorite, I'm usually wrong. It seems like every meteorite sample that we study, we find something unique and different.
We take these really challenging problems and we turn them into technologies that can come back and benefit our economy. My name is Josh Foley, and I develop materials and insulations for extreme temperature environments both in space and on Earth. One of the things that I love about NASA is all the research that is really the backbone of a lot of the technology development that goes on in this country. A lot of the work that is done at NASA is done in conjunction with private sector companies. So a lot of other smaller companies work with us and they develop materials and they build parts. That's exciting, right? I was always interested in technology and working with my hands, building things, figuring stuff out, how do things work. But honestly, I was really intimidated by the math, and I ended up getting a degree in psychology, believe it or not. I graduated and I realized what I really wanted to do was engineering. So I decided I'm just going to do this, and I figured out how to study for calculus and went through the whole thing. And I succeeded and graduated with a master's degree in mechanical engineering. Give yourself a chance and don't be discouraged. If you want it bad enough, you'll find a way to make it happen.
The power of incorporating the knowledge, the common knowledge, into actually solving technology. My name is Masihrahman, and I invite the public to come and help NASA solve really hard challenges.
Centennial Challenges is a NASA program that invites the community, all the public, everybody, to come and help us solve technology problems that are really hard.
I am very much a technology developer. My everything, it's about answering questions and trying to solve puzzles, right? Finding areas of commonality between what we're doing in space and what we're doing for Earth applications with companies that are very much Earth related. You know, the way I'm thinking is different, but I can solve that problem for you. It is amazing, the feeling of being part of something that allows you to think creatively in a new way. That's also super cool.
We hope that we can get to where we can build very complex parts that are required for the rockets in a facility that is building parts for your car and your kitchen. And my name is Jonathan Jones, and I'm working on a number of technologies that will enable low-cost access to space. For me, I'm very interested in the turnaround time that it takes to get from an idea to test data. We can print it, and so our ability to turn that process around faster, so there's feedback to the engineer, so they can print all that linked together, that enables us to take a risk with a new technology, fly it to orbit, see if it works. It's incredible to be able to come to a job every day and play. From as early as I can remember, I enjoyed taking things apart and putting them back together. Rocket science has become a big part of who I am and my life. There are probably more rocket analogies taught in my Sunday school classes than anywhere in the world.
Satellites are crucial to everyday life. If you can prolong their life, it's really a game changer. I'm Brent Robertson. I manage a group of people that build robots to operate in space to refuel other satellites. Right now, you launch a satellite, it operates, and when it runs out of fuel, it's decommissioned. Restore-L is a technology demonstration mission to be able to autonomously rendezvous, capture, robotically service, refuel, and then safely release a client satellite that was not designed to be refueled. We'll be the first to do that. So we do a lot of testing on the ground. It's outfitted with a tool system on its end effector. We don't want to push that satellite away. You know, there's no friction in space holding that satellite somewhere, so you could easily push it away. I just love what I'm doing. How many people get to work on a robot that's going to go up in space, and it's going to be the way of the future. And to think that I was a part of that is a real thrill.
There are other technologies we're looking at that would allow you to kind of suit up immediately and go straight out the door, which is something that our astronauts right now would love to do. My name is Marlon Cox, and I build the next generation of spacesuits. So this is our spacesuit portable life support system. The first moment in my life when I thought about working for NASA was visiting the Kennedy Space Center. I said that's what I was going to do when I was going to grow up. Anytime that you're going out of your vehicle, be it the International Space Station, be it a lunar or Martian hab or some sort of vehicle, you're suiting up and you're going out and you're taking your spacewalk. The life support system has everything you need to stay alive in space. These are the two regulators. That's actually what I work on. So that gives you your breathing air and the pressure that the body needs. The work that we do here at NASA, I think is really important to the future of mankind. And we have an excellent team of people working on it together.
The moment I saw my first laser, I decided that's what I wanted to work with. My name is Abe Biswas, and I'm working on advancing laser communications to deep space distances for destinations like Mars and beyond. Traditionally, the telecommunications from deep space uses radio frequencies. When you go to lasers, you can pack much more information for the same power that you transmit from space. So the challenge in this, of course, is pointing the laser. Because it's such a narrow laser that gives you the high power density, pointing it is very difficult. It's a little bit like skeet shooting because you need to send your beam where Earth is going to be by the time the light reaches. And so light comes in and it gets focused down. Getting information bits on single photons, it still blows my mind. It's like magic almost to me. Exploring space, going beyond the solar system, I think laser communication is going to be critical. I like learning new things, and Not a day goes by in my 21 years of doing laser comm that I don't come into work and learn something new.